Welcome viewers, in this video we will see the solved problem based on the RL series circuit, resistor and inductor connected in series. This is a part 2. Part 1 already available, a separate video, link is available in the description box. First we will see the problem 1. A 10 ohm resistor and 20 millihenry inductor are connected in series across a 250 voltage 60 Hz supply. 10 ohm resistor and 20 millihenry inductor are connected in series, that is across a 250 volt 60 Hz supply. We need to find the impedance of the circuit, voltage across the resistor, voltage across the inductor, apparent power, active power and reactive power. So based on the given data we have R value is available, R is 10 ohm. Inductor L equal to 20 millihenry, that is 20 into 10 to the power minus 3 Henry. The voltage is 250 voltage, the frequency is 60 Hz. First we will find the inductive reactance, then we will go to the other parameters. The inductive reactance XL equal to 2 pi F into L, the formula is available. So 2 into pi into F is 60 and L is 20 into 10 to the power minus 3. By simplifying this we got 7.54 ohm. The inductive reactance is 7.54. So based on this value we can go for the parameter. First we will find the impedance of the circuit. Impedance, the magnitude of Z equal to square root of R square plus XL square. The formula is there. So R square is 10 square, XL is 7.54 square. So by simplifying this we got 12.5 ohm. The impedance of the circuit is 12.5 ohm. Then we will find the voltage across resistor and inductor. Before finding, first we will find the current flowing through the circuit. Because of series circuit, same current is flowing through the resistor as well as inductor. So I equal to V divided by Z, voltage divided by impedance. The voltage is 250, impedance is 12.5. So by simplifying this point we got 20 amperes. So current flowing through the circuit is 20 amperes. Then we will find the voltage across the resistor, VR equal to I into R, that is equal to 20 into 10. I is 20 ampere, R value is 10. So 20 into 10, 200 voltage. Voltage across the resistor is 200. Similarly, the voltage across the inductor, VL equal to I into XL, I into inductive reactance. The I value is 20, the inductive reactance is 7.54. We already calculated. By simplifying this, we got 150.8 voltage. So the voltage across the inductor is 150.8 voltage. Now we will go to the active power. Active power S is nothing but V into I, voltage into current. Voltage is 250, current is 20. So 250 into 20, 5000 VA. The unit for active power is voltage ampere. Then we will find the active power. The active power is VI cos pi. This is nothing but a pi is a power factor, cos pi. So we need a value of cos pi. So first we will find cos pi value. Cos pi equal to R divided by Z. From the Phasor diagram this relation is available. Cos pi equal to R divided by Z. So 10 divided by 12.5, that is equal to 0.8. is lagging. Because of inductive circuit, the current is lagging in the inductive circuit. Current is lagging the voltage. So that it is mentioned as lagging. So now cos pi is calculated so that we can find the active power, that is equal to VI cos pi. V is 250, I is 20 ampere, cos pi is 0.8. So by simplifying this we got 4000 watts. The unit for active power is watts, 4000 watts. Now we will find the reactive power. For reactive power what we need is a sin pi. VI sin pi is the reactive power. So we will find sin pi. Sin pi can be calculated from this relation. Sin pi equal to square root of 1 minus cos square pi. That is sin square theta plus cos square theta equal to 1. From that we framed this equation. Right, now we will substitute 1 minus cos pi value is 0.8. So 0.8 square. By simplifying we got 0.6. The sin pi value is 0.6. So the reactive power V into I into sin pi. V is 250, I is 20, sin pi is 0.6. So that By simplifying, we got 3000 VAR. The unit for reactive power is VAR. For apparent power, the unit is VA. Active power, the unit is watts. The reactive power, the unit is VAR. Now we calculated all the parameters. Now we'll go to the second problem. A coil when connected 200 voltage and 50 hertz supply that takes a current of 10 ampere and dissipated 1200 watts. So one coil is connected with 200 voltage and 50 hertz supply. It will takes the 10 ampere current and dissipate the 1200 watts. In this problem, we need to find the value of resistor and inductor of the circuit. We need to find the resistor value and inductor value. So the given data is voltage is available 200 voltage, frequency is 50 hertz. The current taken is 10 ampere because both are connected in series, same current is flowing, and power dissipated is 1200 watts. So based on that, first we will find the resistor value. So power equal to I square R. The formula is available. Power equal to V into I, one formula. I square R, one formula. V square by R, another formula. Three different formula available. Here we can use this formula because current is available, power is available. So we can use P equal to I square R. We need R value. So bring the I square in the denominator. So P divided by I square equal to R. So the P is 1200, I is 10 square. So by simplifying this, we got 12 ohm. The resistor value is 12 ohm. Now we'll go to the inductor value. Before finding inductor value, first we will find the impedance. Impedance, the magnitude of Z equal to magnitude of V divided by magnitude of I. So that is equal to 200 by 10, that is 20 ohm. The impedance of the circuit is 20 ohm. Next we will find the inductive reactance. How will you find? The formula is available. Z square equal to R square plus XL square based on the impedance triangle. We need XL square. So bring this R square this side. So XL square equal to Z square minus R square. So XL, take square root on both sides. So XL equal to square root of Z square minus R square. So Z is we already calculated 20 square minus R value is 12 ohm, 12 square. So by simplifying, we got 16 ohm. The inductive reactance is 60 ohm. This inductive reactance, another formula is available. Inductive reactance XL is nothing but omega into L. Omega is nothing but angular velocity 2 pi into 2 pi f into L. So the XL value we calculated 16. So 2 into pi into frequency is 50 hertz into L. So this L we need to calculate. So bring this term in the denominator. So 16 divided by 2 into pi into 50. By simplifying this, we got L equal to 50.93 millihenry. Milli means 10 to the power minus 3. So now we calculate a resistance value as well as inductance value. So in this video, we discuss about the solved problem based on the RC series circuit. Part 2. Part 1 also available. Thank you.